In the Amazon, losing sight does not always mean darkness. Sometimes it begins with burning eyes, blurred movement, panic, nerve disruption, or a body that can no longer read the world correctly. A predator does not need to blind prey forever to win. It only needs to ruin perception long enough for escape to fail. A toxin in the eye, venom in the nerves, or pain so intense that vision becomes useless can turn the rainforest into a maze. This episode is about the Amazon creatures that attack one of the body's most fragile survival systems, the ability to see danger clearly before it is too late. The marine toad does not enter the forest like a hunter. It does not glide through the branches, coil in ambush, or stalk the edge of the water with patient eyes. It sits low to the ground, heavy-bodied and almost awkward, with dry, warty skin that looks more like bark, mud, and old leaf litter than living armor. In the damp Amazon night, that plainness is part of the danger. The forest floor is already crowded with shapes that lie still: fallen fruit, curled leaves, broken seed pods, lumps of clay, beetles half buried in the soil. A predator moving through this darkness has to make decisions quickly. The air is warm, the ground is alive with insect movement, frogs call from flooded ditches and temporary pools. Somewhere in that confusion, the marine toad waits with a defense that only works when another animal makes the first mistake. Its body is built around refusal. Behind the eyes, the swollen parotoid glands rise like blunt warning pads, storing a milky secretion rich in defensive chemicals. This is not venom in the classic sense of a snake fang injecting toxins into prey. The toad does not chase an enemy and deliver a precise strike. Its chemistry is passive, but that does not make it weak. The whole defense depends on contact. A bite, a careless mouthful, a predator pressing its nose into the wrong skin, a tongue grabbing what looked like easy food. The moment those secretions reach soft tissue, the situation changes. Eyes, gums, tongue, nostrils, and the inside of the mouth are not protected like scales or fur. They are sensitive, wet, and full of nerves. That is where the toad's defense becomes personal. For a hungry predator, the first error may feel like success. The toad is slow. It does not vanish with the explosive leap of a smaller frog. It does not climb away or dive into deep water. A mammal, bird, snake, or reptile might see a bulky amphibian and read it as a simple meal, protein wrapped in soft skin. But evolution has turned that softness into a trap. When pressure squeezes the glands, the secretion can smear across the attacker's mouth or face. The punishment is not cinematic at first. There is no dramatic blast, no visible cloud of poison. Instead, the face becomes the battlefield. Burning irritation can flood the mouth and eyes. Saliva thickens. The predator may paw at its snout, shake its head, blink hard, or lose the clean focus needed to continue the attack. The toad survives because it does not need to win a fight. It only needs to make the predator regret touching it before the bite becomes fatal. That is what makes the marine toad so disturbing inside a video called Blind Strike. The strike is not made by the toad's jaws. It is made by the attacker's own confidence. The predator closes in, and the defense fires backward through contact. Vision becomes unreliable not because the toad is literally designed to destroy the optic nerve like a surgical weapon, but because the eyes are exposed tissue, and chemical irritation can turn sight into pain, watering, blinking, and confusion. In the wild, even temporary visual failure matters. A hunter that cannot aim properly, track movement cleanly, or judge distance loses its advantage in seconds. The forest does not pause while an animal recovers. Insects keep crawling. Other predators keep listening. A misstep near water, a stumble through roots, or a few moments of disorientation can turn the attacker from hunter into vulnerable animal. The chemistry itself is more than just surface irritation. Marine toads produce toxins, a mix of compounds that can affect the heart, nervous system and muscles when enough toxin is swallowed or absorbed through mucous membranes. That is why the mouth is such a dangerous entry point. A predator does not need to swallow the whole toad to get into trouble. A hard bite can be enough to spread toxin across the gums and tongue, where absorption can happen quickly. Smaller predators are especially at risk because dosage matters. What irritates a large animal can overwhelm a smaller one. In ecological terms, this is a brutally efficient defense. The toad does not need a different strategy for every enemy. It carries a chemical warning that punishes the universal tools of predation: bite, taste, smell, and close inspection. There is also a strange honesty to the animal's appearance. Many toxic creatures advertise danger with bright colors, sharp patterns, or impossible beauty. The marine toad is uglier and more practical. Its warning is not elegance. It is texture, size, posture, and the thick glandular swelling behind the head. To a predator that has learned from experience, that shape can be enough. A toad sitting motionless on wet soil may be ignored not because it is invisible, but because it is remembered. That memory is one of nature's harshest teachers. A young predator may survive its first bad mouthful and never repeat the mistake. In that way, the toad's defense reaches beyond the individual attack. It reshapes future behavior. It writes a warning into the nervous system of the animals around it. The Amazon floor is the perfect stage for this kind of chemical warfare because food is everywhere, but safe food is not. Night hunters move through a world of partial information. A snake follows scent trails with its tongue. A small carnivorous mammal noses through vegetation for movement. Birds and reptiles react to flashes and silhouettes. The marine toad exploits that uncertainty. It does not need to outrun a predator if the predator hesitates before biting. It does not need armor if its skin can make a mouthful dangerous, and it does not need to kill its attacker for the defense to work. Escape often depends on a narrow window. The attacker releases, recoils, wipes its face, or loses coordination for a moment. That moment is enough for the toad to flatten itself into the dark, push toward cover, or simply become too unpleasant to continue handling. There is a bitter kind of irony in it. The marine toad looks like one of the easiest animals in the forest to overpower, yet its real weapon punishes exactly the predator that thinks that way. Speed invites pursuit. Teeth invite caution. Bright colors invite suspicion. But a dull, heavy amphibian invites arrogance. The toad turns that arrogance into the delivery system. The predator brings the sensitive tissue. The predator applies the pressure. The predator opens the gate for the toxin. This is why the marine toad works as the opening chapter. It grounds the horror in something believable, not fantasy blindness, not magical venom, but anatomy meeting chemistry at the worst possible surface. Eyes are powerful because they are exposed. A mouth is dangerous because it is absorbent. A predator's face, built to investigate and attack, becomes the weakest part of its body. In the Amazon, survival is not always about being faster, stronger, or more hidden. Sometimes the winning strategy is uglier and colder than that. You let the enemy come close. You let it believe it has found an easy meal. Then you make contact itself feel like a mistake. Poison dart frogs do not hide from the forest in the way most small animals are expected to hide. They are tiny, soft-bodied, and surrounded by mouths larger than their entire skeleton, yet many of them move through the wet leaf litter as if the rules have been rewritten in their favor. In the low green light of the rainforest, where fallen leaves rot into the soil and every surface seems to sweat, a flash of blue, yellow, orange or red does not disappear into the background. It cuts through it. The color feels almost wrong at first, too clean against mud, moss, bark and shadow. But that is the point. The frog is not trying to be invisible. It is trying to be understood before anything gets close enough to make a fatal mistake. In most prey animals, visibility is a weakness. A careless movement draws the eye of a snake. A bright wing can betray an insect to a bird. A body exposed on a leaf becomes an invitation. Poison dart frogs turn that logic around through aposematism, the biological language of warning color. Their skin is not just beautiful, it is a sign system shaped by generations of failed attacks. The message is brutally simple: remember this color or suffer for ignoring it. The predator's eyes become the first line of defense, not because the frog attacks through sight, but because vision gives the predator a chance to stop itself. The frog is seen before it is touched. In that tiny pause between recognition and contact, evolution has placed a warning label bright enough to survive the chaos of the forest floor. That warning matters because a poison dart frog is not protected by strength. It cannot wrestle a bird's beak open. It cannot outrun every snake. It cannot survive being chewed like an ordinary frog. Its defense lies in the chemical compounds stored in its skin, especially alkaloids collected from its diet in the wild. Many poison dart frogs do not manufacture their most dangerous toxins from nothing. They acquire them by eating small arthropods such as ants, mites and beetles, then sequester those chemicals in skin glands. The frog becomes a living container for the chemistry of its ecosystem. Its poison is not separate from the rainforest. It is made out of the rainforest, filtered through food webs so small that most viewers would never notice them crawling under a leaf. That detail makes the animal more interesting than a simple "deadly frog" label. A captive poison dart frog raised without its wild diet often loses much of its toxicity because the chemical supply chain has been broken. In the forest, however, every tiny prey item can become part of the frog's defense system. The frog hunts insects. The insects carry alkaloids, and the frog stores those compounds in its skin until a predator tests the warning. This is not random poison splashed across an animal. It is ecological chemistry built from diet, habitat, and selection pressure. The frog's color is the advertisement, but the real weapon begins far below the viewer's attention, in the unseen economy of mites, ants, decaying wood, and wet soil. The brightest species are often active during the day, which makes sense once the warning system is understood. At night, color loses some of its power. In daylight, it becomes a broadcast. A small frog climbing over a root or resting on a broad leaf can be read from a distance. Its body does not need to be large if the pattern is loud. The colors break the normal camouflage code of the rainforest and force the predator to process a different kind of information. A young bird, a lizard, or a small mammal may pause over that impossible little shape. If it has learned from experience, it backs away. If it has not, the lesson may be delivered through burning taste, sickness, loss of coordination, or more serious internal effects, depending on the species and toxin involved. The eyes are central here because this entire defense begins with perception. Predators survive by reading the world correctly. They separate food from threat, shadow from body, movement from wind. Poison dart frogs exploit that same decision-making system. Their color is not meant to please us. It is meant to interrupt a predator's hunting sequence. See, recognize, avoid. That is the ideal outcome. The frog does not want to be bitten. A poison defense that only works after being swallowed is a poor bargain for a fragile animal. The warning color solves that problem by pushing the danger outward, away from the skin and into the predator's brain before contact happens. In the cleanest version of the strategy, no attack occurs at all, but the forest is never clean. Young predators are reckless, hungry animals misjudge risk. Some attackers strike from reflex before recognition catches up. When the warning fails, the frog's skin becomes the final argument. Contact with the mouth is especially dangerous because mucous membranes absorb chemicals more readily than dry outer skin. The predator may spit, shake, wipe its face, or freeze in confusion as taste and nerve signals turn against it. For a small animal trying to kill quickly, even a few seconds of disorder matter. A missed strike, a watering eye, an irritated mouth, or a sudden wave of nausea can end the attack. The frog's survival depends less on overpowering the predator and more on making the predator's own senses unreliable. There is a quiet cruelty in how precise the system is. The predator sees the warning, ignores it, and then suffers through the very surfaces it uses to hunt. Eyes to locate, tongue to test, mouth to seize. Beauty becomes a trap only for the animal that refuses to read it. To human eyes, these frogs look like jewels placed carefully on wet leaves. To the rainforest, they are walking hazard signs. The same colors that make them irresistible on camera are the colors that tell experienced predators to keep moving. Their lives are not only about poison either. Many poison dart frogs show complex parental care that feels almost too delicate for such chemically defended animals. Adults may guard eggs laid in humid shelters, then transport tadpoles on their backs to tiny pools formed in bromeliads, tree holes, or curled leaves. In some species, the parent returns repeatedly, navigating a vertical maze of plants and water pockets to keep offspring alive. The frog that looks like a simple flash of color is also part of a precise reproductive strategy shaped by rainfall, humidity, and the architecture of the forest. A drying pool can mean death. A protected plant cup can become a nursery. The rainforest is not just a backdrop. It is a system of temporary rooms, each one offering safety or failure depending on timing. This is why poison dart frogs belong so strongly in blind strike. They bring a different kind of danger from the marine toad. The toad punishes contact through ugly surprise. The poison dart frog tries to prevent contact through visual honesty. It announces itself so clearly that the predator has to be almost foolish, inexperienced, or desperate to continue. Yet, that is what makes the scene tense. The most visible animal in the frame is not helpless. The bright body on the leaf is not asking to be eaten. It is speaking in the oldest language of survival. Remember pain before pain has to return. In the rainforest, beauty is never just decoration. It can be camouflage, courtship, deception, or warning. With poison dart frogs, it becomes a contract written between prey and predator. The frog promises nothing gentle if that contract is broken. Its color says the fight is already being decided before the bite, before the mouth closes, before the eyes finish judging distance. A predator that understands the message lives a little wiser. A predator that ignores it learns that the smallest bright thing in the forest may be carrying the loudest consequence. The Brazilian wandering spider brings a different kind of fear into the rainforest. It is not a bright warning sign like a poison dart frog, and it is not a slow chemical trap like a marine toad. It moves with intent. At night, when the heat begins to loosen from the leaves and the forest floor becomes active with insects, frogs, lizards, and small mammals, this spider becomes part of the darkness itself. It does not wait in the center of a web like a patient architect. It walks, it searches. It tests the ground with long, sensitive legs, reading the world through vibration, scent, air movement, and contact. In a place where so much life hides by staying still, the wandering spider survives by becoming a moving threat, a hunter that does not need silk walls to control the moment. On the rainforest floor, vision is already unreliable. Roots twist through mud. Fallen leaves overlap in wet layers. Every patch of darkness may be a hole, a beetle, a frog, or nothing at all. For a small animal moving through this space, the body depends on fast interpretation. A rustle means food or danger. A shadow means cover or ambush. A sudden touch means react before thinking. The Brazilian wandering spider fits perfectly into that confusion. Its body is low, fast, and difficult to read against bark, soil, and dead leaves. It can freeze so completely that it becomes part of the forest texture, then shift forward with startling speed when prey comes within reach. The danger is not only in the bite, it is in how quickly a normal piece of ground can become a living weapon. Its venom belongs to the nerve side of blind strike, because it does not simply damage tissue at the surface, it interferes with communication. Nerves are the body's electrical language, carrying signals that control pain, movement, pressure, breathing, heart rhythm, and stress responses. Venom from Phonutria spiders contains a complex mixture of molecules, including neurotoxic peptides that can affect ion channels, the tiny gateways that help nerves fire properly. That sounds technical, but inside a bitten animal, it becomes brutally physical. Pain can surge through the bite site, muscles may twitch or weaken. The body may flood itself with distress signals, sweating, agitation, rising heart rate, unstable movement, and a sense of internal alarm that no longer matches the outside world. The animal is not just injured, its own control system begins to betray it. That is what makes this spider so dangerous in a dense forest. A bitten animal still has to function. It still has to climb, run, hide, balance, breathe, and decide where danger is coming from. But venom can turn those decisions messy. Panic movement is rarely clean movement. A lizard that normally slips between roots may stumble into open ground. A small mammal that depends on tight body control may waste precious seconds shaking, grooming, or jerking away from pain. A frog struck during a night movement may kick hard but fail to direct its escape properly. In the rainforest, survival is often decided by narrow margins. One bad landing, one delayed retreat, one confused turn toward the wrong shadow can be enough. The spider does not need to blind prey in the literal sense to break its world. Vision is only one part of awareness. A body under chemical stress reads everything badly. Pain becomes louder than direction. The forest becomes harder to map. Every sensation competes for attention at once. This is the deeper horror of neurotoxic venom. It attacks the coordination between perception and action. An animal may still see leaves, roots, and escape routes, but the clean line between seeing and moving is damaged. The eyes may be open, yet the body is no longer obeying with the same precision. In that way, the blindness is functional. The world is visible, but it is no longer usable. The Brazilian wandering spider's hunting style makes that effect even more effective. Unlike a web-building spider that waits for prey to become trapped, this spider often relies on active pursuit and close-range contact. Its legs are covered in sensory hairs that detect faint vibrations and air shifts. A cockroach moving under a leaf, a cricket brushing against debris, or a small frog shifting in the dark can reveal itself without ever being clearly seen. The spider's world is not built mainly from images, it is built from touch and tremor. That gives it an advantage in a habitat where light is broken by vegetation and shadow. When it closes the distance, the bite delivers venom into a body that may be only seconds away from being restrained. There is also a defensive side to its reputation. Brazilian wandering spiders are famous for raising the front of the body and spreading the legs when threatened, a posture that makes the animal appear larger and more confrontational. It is not aggression for drama's sake, it is warning behavior. A venomous animal benefits when danger backs away before contact. Venom is costly to produce, and biting a large enemy is risky. The display buys space. But if a predator, a careless animal, or a larger threat pushes too close, the spider can turn from warning to contact with shocking speed. The same venom that helps subdue prey can become a defensive emergency tool, forcing the attacker into pain, confusion, and retreat. This is where the spider becomes more than a dangerous bite story. It reveals how much rainforest survival depends on nervous system accuracy. Every animal in the forest is constantly processing signals. Frogs listen for water and mates while avoiding snakes. Small mammals smell fruit, insects, and predators at the same time. Birds judge distance through branches while reacting to movement below. Reptiles rely on heat, scent, vibration, and vision to decide whether to strike or flee. A neurotoxic bite attacks this invisible decision-making network. It makes the body noisy from the inside. The victim may still possess claws, legs, eyes, and instincts, but the venom pushes those tools out of rhythm. For prey, the spider's bite can mean the difference between struggling and being controlled. For a predator that tries to eat the spider, the same chemistry becomes punishment. Many rainforest hunters are opportunists, and a large spider may look like a decent meal to a bird, reptile, or mammal. But grabbing a wandering spider is not like grabbing a harmless insect. The legs, fangs, speed, and venom all make the encounter unstable. If the attack is not clean, the predator may receive the full cost of its mistake. A mouth, paw, or face brought too close can become the entry point for pain. And once pain interrupts focus, the hunter's advantage begins to collapse. The irony is that the spider itself is not invincible. It is still prey to many animals: wasps, birds, reptiles, mammals, and other arthropods all place pressure on spiders in the rainforest. Its venom is powerful, but power does not remove risk. It simply changes the terms of contact. The spider must still avoid being crushed, trapped, or swallowed too quickly to bite. It must manage temperature and moisture, shelter during vulnerable hours, and hunt without becoming exposed. Like many nocturnal hunters, it lives inside a balance of boldness and caution. Too hidden, and it misses food. Too exposed, and it becomes food. That balance is what makes it compelling on camera. The Brazilian wandering spider is not a monster dropped into the jungle. It is a precise product of the jungle's demands: darkness, clutter, speed, hunger, and constant close-range danger. Its venom is not just a weapon of pain, it is a way to disrupt the deepest machinery of survival. A bitten animal does not only feel hurt, it feels the forest become harder to understand. The ground becomes less certain. The next movement becomes less controlled. Escape becomes less clean. In Blind Strike, this chapter shifts the threat from the eyes to the entire nervous system. The spider does not need color to warn, or glands to punish a bite, or hairs to irritate the face. It brings the attack inside the wiring. It shows that in the Amazon, losing control can be just as deadly as losing sight. The forest is already difficult enough when the body is working perfectly. When venom turns pain, panic, and movement against the victim, the darkness does not need to change at all. The animal changes instead, and in a place where every second of confusion can be noticed by something else, that may be enough. Venomous caterpillars are dangerous in a quieter, dirtier way than the animals that advertise themselves with bright skin or swollen poison glands. They do not need to look powerful. They do not need to move fast. Many barely seem to move at all, inching along bark, leaves, vines, and low branches with the slow confidence of something that has made stillness part of its defense. In the rainforest, where every surface is crowded with moss, fungus, lichens, thorns, ants, eggs, and fragments of dead leaves, a caterpillar can become almost impossible to separate from the texture around it. It may look like a soft tuft of hair, a strip of moss, a strange patch of plant fiber, or a harmless piece of living fuzz. That is exactly where the danger begins, because the encounter often happens before the predator has fully understood what it touched. On a wet Amazon morning, the forest does not present clean boundaries. Leaves overlap. Branches bend under moisture. Tree trunks sweat under films of algae and fungus. A hunting bird searching for insects, a small mammal climbing through vines, or a reptile pushing its head into foliage does not inspect every surface like a scientist. It moves by hunger, scent, motion, and opportunity. A caterpillar resting against bark may not trigger fear at all. It is small, slow, and apparently fragile. But across its body, hidden among the hairs or branching spines, is a defensive system designed for close-range punishment. Some species carry urticating hairs that break off and irritate tissue. Others have hollow or venom-bearing spines connected to glands, turning a careless brush into dozens of tiny injections. The attack is not dramatic because the caterpillar does not launch it. The attacker delivers the punishment to itself. That is the cruel genius of this defense. A predator expects resistance from teeth, claws, venomous fangs, or a fleeing body. It does not expect the surface of a small larva to behave like a biological minefield. The spines can snap, lodge, or scrape into skin, lips, nostrils, eyelids, or the soft tissue around the mouth. What follows may begin as a sharp sting or burning itch, but it can quickly become swelling, throbbing pain, inflammation, and frantic irritation. For humans, some caterpillar encounters are known to cause intense dermatitis. Certain South American species, especially in the genus Lonomia, are infamous for venom that can interfere with blood clotting and lead to serious systemic illness. In a predator's world, the exact medical category matters less than the immediate result. Pain arrives from something that looked edible, and the body suddenly becomes harder to control. The eyes make the whole encounter worse. A paw can withdraw. A tongue can spit something out. A beak can scrape against bark. But the eye is a wet, delicate surface built for exposure. It has to remain open to read the environment, yet that openness makes it vulnerable to the smallest particles. Caterpillar hairs or spines near the face can turn a minor mistake into a survival problem. Irritation around the eye can cause watering, blinking, swelling, and temporary loss of clean vision. In some cases, tiny hairs can become embedded and continue causing inflammation. For a predator, that does not need to mean permanent blindness to become dangerous. The forest punishes even short confusion. A bird that cannot focus properly misses the next branch. A lizard that keeps rubbing its face loses the insect it was following. A small mammal distracted by pain becomes less aware of snakes, raptors, or larger hunters moving nearby. This is why venomous caterpillars fit so well into the logic of blind strike. The strike is not a leap or a bite. It is contact turned against the animal that made contact. The caterpillar survives by making the predator's most important tools unreliable. Vision blurs through watering and irritation. Smell and taste become overwhelmed if hairs touch the nose or mouth. Clean movement breaks down when pain forces the body into rubbing, shaking, or retreat. The predator does not need to collapse. It only needs to lose precision. In a rainforest built from edges, drops, hidden water, thorns, and ambush points, precision is not a luxury. It is survival. The caterpillar itself is in one of the most vulnerable stages of an insect's life. It is not yet a moth or butterfly, not yet capable of flight, not yet hidden inside the adult form that many people recognize. Its job is brutally simple: eat, grow, and survive long enough to transform. That creates an evolutionary problem. A caterpillar is basically a soft feeding machine filled with nutrients, and almost every insect-eating predator in the forest has a reason to notice it. Birds scan leaves for them, wasps hunt them, ants cut across their paths, lizards and frogs take them when they can. To survive this pressure, caterpillars have evolved a wild range of solutions: camouflage, false heads, snake-like eye patterns, chemical defenses, group living, silk shelters, and painful spines. Venomous or irritating structures are one of the most direct answers to the question of how a soft body survives in a world of mouths. The shapes can be strangely beautiful, but that beauty is not gentle. Some caterpillars carry branching spines that look like tiny trees of glass. Others are hidden under dense hair, giving them a plush appearance that seems almost designed to tempt touch. That is where human instinct gets fooled, and predators can be fooled in their own way. Softness suggests safety. Fuzz suggests harmlessness. In reality, those textures may be warning architecture. The caterpillar's body is not asking to be handled. It is covered in structures that make handling expensive. Even their stillness has a purpose. Many caterpillars feed in exposed places because leaves are their food, but exposure does not always mean helplessness. A motionless larva against a leaf vein can disappear from a distance. If detected, its spines create hesitation. If touched, the defense finally becomes physical. Some species strengthen that strategy through group behavior, clustering together so a predator approaching one caterpillar may meet an entire patch of painful spines. A single caterpillar is unpleasant. A cluster becomes a living warning mat. For a bird landing too quickly or a monkey brushing a branch with its face, the cost of not looking closely can be immediate. There is also a deeper ecological truth hiding in these small bodies. Caterpillars are not side characters in the rainforest. They are major links between plants and everything that eats insects. They convert leaves into animal tissue, feeding birds, reptiles, amphibians, spiders, wasps, and mammals. Their defenses are part of a constant argument between plants, herbivores, and predators. Plants produce chemical compounds to protect leaves. Caterpillars evolve ways to tolerate, store, or avoid those compounds. Predators evolve ways to find caterpillars despite camouflage. caterpillars answer with spines, toxins, warning colors, or disguise. The forest is not peaceful abundance. It is a layered contest of chemistry and recognition, and the caterpillar is one of its busiest battlegrounds. For the camera, the horror is in the scale. A jaguar, caiman, or snake announces danger through size and intent. A venomous caterpillar can sit unnoticed on a branch at eye level, waiting inside the ordinary texture of the forest. The threat is not that it hunts you. The threat is that the world is so crowded with life that contact becomes unavoidable. A predator lunges at one insect and brushes another. A face pushes through leaves. A paw grips bark. A tongue strikes at the wrong patch of movement. Suddenly, the soft-looking thing has rewritten the moment. Pain travels faster than understanding. That makes the caterpillar one of the most honest examples of hidden rainforest cruelty. It does not pretend to be a monster. It does not need drama. Its body simply proves that danger can be small, quiet, and already touching you before your brain names it. In a place where survival depends on reading color, texture, movement, and distance correctly, venomous caterpillars punish the smallest mistake. They remind every predator that not all weapons point outward like teeth. Some wait in the hairs, in the spines, in the surface itself, ready to turn one careless brush against bark into burning confusion, swollen eyes, and a sudden failure to move cleanly through the living maze. The black widow brings a colder, quieter pressure into blind strike. It does not dominate the forest floor with size. It does not need bright skin, a swelling gland, or a dramatic chase through the leaves. Its danger is built into patience, darkness, and a web that turns empty space into a trap. In the shaded corners of the tropical world, under loose bark, inside hollow wood, between roots, stones, leaf litter, and abandoned shelter. A black widow can become almost invisible until something has already crossed the wrong line. The forest around it may feel loud with frogs, insects, dripping water, and night birds, but the spider's hunting zone is strangely still. Nothing about it announces panic. That stillness is part of the threat. A black widow's web is not the elegant wheel-shaped net many people imagine when they think of spiders. It is messier, tougher, and more practical, a three-dimensional tangle of silk lines stretched through hidden gaps. To an insect crawling through darkness, those threads are not decoration. They are pressure sensors, trip wires, and restraints. The spider waits with its body held close to cover, reading the web through vibration. It does not need to see prey clearly in the way a bird or lizard does. It feels the struggle through silk. A beetle, cricket, fly, or small arthropod that blunders into the trap creates a pattern of movement, and that pattern tells the spider where to strike. In this world, vision is already secondary. Touch becomes the map. The bite itself can look almost underwhelming compared with what follows. There may be no massive wound, no tearing impact, no obvious destruction at the surface. That is what makes the black widow so unsettling. Its venom is designed to attack function more than flesh. In humans, black widow bites can cause latrodectism, a syndrome marked by severe muscle pain, cramping, sweating, tightness, nausea, and distress that may spread far beyond the original bite site. The key compound, alpha-latrotoxin, disrupts communication at nerve endings, forcing the release of neurotransmitters and throwing normal signaling into chaos. Put simply, the body's messaging system is pushed too hard. Signals that should be controlled become excessive, painful, and disorganized. For the spider's natural prey, this kind of disruption is devastating. An insect caught in silk already has limited options. The more it kicks, the more the web reads its location. The more it struggles, the more lines can tighten or stick. When venom enters the body, the victim is not just physically trapped. Its own muscles and nerves begin to fail the escape attempt. Movement becomes less useful. Coordination breaks down. The spider's small bite becomes a much larger event inside the prey. That is the frightening efficiency of venom in miniature predators. The wound does not need to be large when the chemistry knows where to go. This is where the chapter fits the title, "Without pretending blindness always means damaged eyes." In nature, sight is only valuable if the body can act on what it sees. An animal can stare directly at an escape route and still be doomed if its muscles are locking, its abdomen is cramping, its limbs are misfiring, and pain is overriding clean decision-making. The forest may remain visible, but visibility no longer equals control. A small predator or insect caught near a widow's web might sense open space nearby, feel air moving through leaves, even detect the direction of safety. But the body cannot turn that knowledge into movement fast enough. The eyes, if the animal relies on them, are open. The world is still there. The connection between perception and survival has been cut by pain. The black widow's power also comes from its restraint. Venom is biologically expensive. It is not thrown away like waste. A spider must balance the value of a bite against the risk of contact, because close-range hunting is dangerous even for venomous animals. Prey can kick, bite, sting, or tear through silk. Larger animals can crush the spider before venom matters. This is why the web is so important. It gives the black widow distance, information, and control before the bite happens. Silk does the first part of the work by slowing the victim, and venom finishes the argument by making the victim's own nervous system unreliable. There is a strange elegance in that division of labor. The web controls space. The venom controls the body. Together, they create a trap that is not just physical, but sensory. A trapped animal receives confusing information from every direction. The legs feel silk. The body feels tension. The nerves feel pain. The world becomes a storm of signals with no clean solution. That is the Black Widow's version of collapse. Not explosive violence, but a tightening system where each second makes escape less likely. In the wider ecosystem, the Black Widow is not just a symbol of danger. It is part of the forest's hidden sanitation and population control. Spiders remove enormous numbers of insects and other small arthropods from ecosystems, quietly shaping what survives around leaves, roots, fallen trunks, and human edges. A single widow tucked under shelter may spend its life intercepting prey that would otherwise feed, breed, or become food for something else. It is both predator and prey, feared by small animals but vulnerable to birds, wasps, reptiles, ants, and larger spiders. Its venom is powerful, but it doesn't make the animal invincible. It makes a fragile body dangerous enough to survive in a world where fragility usually gets eaten. Even the famous female reputation has a biological reality behind it, though the popular myth often makes it too simple. Female black widows are usually larger and more venomous than males, and in some situations sexual cannibalism can happen, but it is not a guaranteed ritual every time. The real story is more practical. Size, hunger, timing, stress, and escape opportunity all matter. In the wild, mating is not theater. It is risk management under pressure. A male entering a female's web is entering the same sensory system that detects prey. He must signal carefully through vibration, announcing himself in a way that says mate, not meal. Even reproduction becomes a negotiation through silk. That detail reveals something deeper about the spider's world. The black widow lives by interpreting vibrations. Its web is not just a trap, it is an extension of the body. Through silk, the spider can detect prey, threats, mates, and changes in the surrounding structure. For an animal with limited eyesight compared with many predators, silk becomes a sensory organ spread into the environment. This reverses the usual idea of blindness. The spider does not need a wide visual field to dominate its tiny territory. It has built a different kind of awareness, one that turns touch into distance. Against that, a bitten victim is forced into the opposite condition. Its senses may still exist, but they become less useful as pain spreads and muscles tighten. This is the cold horror of the Black Widow chapter. The danger is not that the victim cannot see. The danger is that seeing becomes irrelevant. A body in distress does not move like a calm body. It jerks, freezes, curls, overreacts, and wastes energy. In a dense habitat, wasted motion is deadly. It reveals location. It deepens entanglement. It burns the short supply of strength that might have been enough for escape. The Black Widow belongs in blind strike because it shows that sensory collapse can begin far from the eyes. The smallest puncture can become a whole body crisis. The web can make space unreadable. The venom can make movement unreliable. The animal caught in that system is not defeated by one dramatic wound, but by a slow betrayal of coordination. It can still see the forest, still sense the air, still know danger is close, but knowledge is worthless when the muscles refuse to answer properly. In the end, the Black Widow proves one of the darkest rules of survival. The body does not need to be destroyed to lose. It only needs to stop obeying at the exact moment escape matters most. The coral snake closes blind strike with a different kind of fear. It is not loud in its behavior. It does not charge across the forest floor, rear up dramatically, or dominate the scene with size. It moves like a secret passing through leaves, slipping under damp litter, between roots, along the soft edges of fallen logs, where the rainforest floor holds heat and moisture long after sunset. Its body is narrow, polished, and almost too perfect against the broken mess of the Amazon ground. Bands of red, black, yellow, or white interrupt the mud-colored world around it, bright enough to be seen, clear enough to be remembered, yet often ignored by animals that do not understand what the pattern means. That is the sinister part. The warning is visible. The danger is real. But the cost of misreading it may not arrive with immediate drama. A coral snake does not look like a heavy ambush predator. It does not have the massive head of a pit viper or the thick body of a constrictor. It appears delicate, almost fragile, especially compared with the larger snakes that haunt rivers, burrows, and forest edges. But that smallness is misleading. Coral snakes belong to the elapid lineage, the same broad venomous family that includes cobras, kraits, taipans, and mambas. Their venom system is built around fixed front fangs and powerful chemistry, not brute force. In many coral snakes, the fangs are short, and the bite may not look as violent as the strike of a viper. That is exactly why the danger can feel so cold. The wound may seem minor, the animal may pull away, and for a moment the forest may appear unchanged. But venom does not need a dramatic entrance to become serious. This chapter belongs at the end because it shows the deepest version of visual failure. The eyes can still see. The world can still be bright, detailed, and close. A bitten animal may still recognize the shape of a branch, the opening under a root, the direction of shelter, or the shadow of an approaching predator. But sight is only useful when the body can answer it. Coral snake venom can contain neurotoxins that interfere with the communication between nerves and muscles. That communication is what allows an animal to lift its head, place its feet, breathe rhythmically, strike, flee, or hold itself upright. When venom begins to disturb that system, survival becomes stranger and more terrifying than blindness. The animal is not lost because the world disappears. It is lost because the command to move no longer travels cleanly from intention to muscle. In the dense Amazon, that failure is brutal. Nothing here is simple terrain. The ground is a layered obstacle course of vines, leaf litter, thorns, rotting wood, muddy pockets, hidden water, insects, and roots slick with decay. Movement must be precise. A small mammal escaping through this world needs its limbs to obey instantly. A lizard must grip bark at the exact angle. A frog must launch with enough force and direction to land somewhere safer than where it started. Even a predator testing the coral snake as prey depends on timing and coordination. If neurotoxic venom begins weakening that coordination, the forest itself becomes harder. The same path that was passable minutes earlier becomes a maze the body can no longer solve. The coral snake's colors add another layer to the story. In many animals, bright patterns are not decoration. They are warnings, shaped by natural selection. Aposematic color works because predators learn to connect a visual signal with a bad experience. The coral snake's banding makes it memorable, and in some places that warning has become so powerful that harmless snakes have evolved similar patterns, gaining protection through resemblance. This mimicry is one of the rainforest's more elegant tricks. A non-venomous snake that looks enough like a coral snake may be avoided by predators that have learned caution. But mimicry also proves the strength of the original message. The coral snake's pattern matters because the animal behind it is dangerous enough to change how other species are seen. Still, warning colors are never perfect. Young predators make mistakes. Hungry predators take risks. Some animals attack from reflex before recognition catches up. Others may grab the snake from behind, dig it out of leaf litter, or encounter it in cramped spaces where avoidance happens too late. Coral snakes are often secretive, spending much of their lives hidden under debris, in soil, or moving through cover, hunting other small reptiles, amphibians, and even other snakes. Their danger is not built for spectacle, it is built for close contact in narrow places. A strike in that world may be quick, controlled, and almost visually small, but the consequence unfolds inside the victim's wiring. For prey, the venom's purpose is efficiency. A snake that feeds on other reptiles or small active animals cannot afford endless wrestling. Lizards twist, frogs kick, smaller snakes coil and bite back. Neurotoxic venom helps reduce that struggle by attacking the system that makes struggle possible. Muscles are not independent machines. They depend on signals, chemical messengers, and nerve impulses arriving in the correct rhythm. Interrupt that rhythm, and strength loses meaning. A body can still contain energy, instinct, and panic, but if the signal fails, the movement weakens. This is the coral snake's cold advantage. It does not need to tear prey apart with force. It can turn the prey's own communication system into the weak point. That is also why the bite can be underestimated. With some venomous animals, the damage announces itself quickly through swelling, bleeding, burning tissue, or visible collapse. Coral snake envenomation can be more deceptive, especially because the surface wound may not seem impressive. But the nervous system does not advertise damage the way torn flesh does. It fails through function. Weakness creeps into movement. Breathing may become harder if the muscles responsible for respiration are affected. Response slows, control thins out. The victim may still be conscious, still seeing, still aware of danger, but awareness becomes trapped inside a body that is losing its ability to act. There is something especially disturbing about that because it attacks the viewer's basic idea of survival. We like to imagine that seeing danger gives an animal a chance. See the snake, avoid the snake. See the branch, leap toward it. See the predator, run. But nature is not that generous. Sight is only one link in a chain. The eye must detect, the brain must interpret, the nerves must transmit, the muscles must respond. The lungs must keep oxygen moving, the heart must support the effort. Coral snake venom threatens the chain after vision has already done its job. The victim may see perfectly and still fail because the machinery behind action is being chemically silenced. The snake itself remains part of the ecosystem, not some villain outside it. It is predator, prey, warning sign, and evolutionary pressure all at once. Raptors, larger snakes, mammals, and other hunters may still threaten it. Its bright bands do not make it invincible. Its secretive habits protect it as much as its venom does. Moving undercover reduces encounters. Hunting in hidden spaces keeps it close to the animals it can overpower. Like many venomous creatures, it benefits most when the warning works and conflict never happens. Venom is valuable, and every dangerous encounter carries risk. The coral snake's best victory is often being noticed and left alone. That makes it the perfect final animal for this episode. The marine toad punished the face. Poison dart frogs turned vision into warning. Caterpillars hid pain inside texture. Wandering spiders disturbed the nervous system through panic and chemical chaos. Black widows showed how pain can make sight useless. The coral snake brings all of those ideas into a quieter, darker conclusion. It reminds us that the most frightening failure is not always the loss of the eyes. Sometimes the eyes keep working, and that is what makes it worse. The animal sees the forest, sees the escape route, sees the danger coming closer, but the body cannot answer with the speed survival demands. In the Amazon, vision is never enough by itself. The forest is too fast, too crowded, too unforgiving. To survive here, an animal must not only see the world correctly, it must turn that sight into movement before something else reacts. The coral snake closes the story by attacking that final truth. Its colors warn from the outside, but its venom works from within. It does not need to cover the eyes in darkness. It can leave the world visible while cutting the body away from action. And in a rainforest where every second matters, that may be the most sinister blindness of all.